In this section, we will discuss about the views of data. So we need to know the concept of data abstraction. So what is data abstraction? Data abstraction is the process of hiding unwanted or irrelevant details from the end user. So let the user, we are trying to hide the complex information or the complexity of the design of the structure, how the data is going to be stored from the end user. We need to do some abstraction process. So data abstraction is basically we are trying to hide unwanted or irrelevant information like complicated data structures or any relations or the relationships used in the database systems. All that is not actually relevant to the user. So from the client side, from the end user. So we try to hide those information. So this process is called as data abstraction. So data abstraction has different views and support in attaining the data independence, which is used to enhance mainly to enhance the security of data. So we have different views of data. So we'll discuss that in the next slide. To make the easy access of the data by the users only, the complications are kept hidden. Okay. So if you want let the user be unaware about all this complex relationships between the design and how the data is stored or how what is the structure, if they are unaware, so it is very easy for them to understand the process and just make an easy access to the data. So that's the reason why we do data abstraction, to just keep the users easy access of data by avoiding all the complication or hiding the complication from the data from the user. So we have various views of data. Under that, we have various levels of abstraction. So just now we saw what was data abstraction. So how are we going to hide the data from the user? In what are the various levels or the ways by which we are going to hide the complexity information from the end user? So in terms of that, we have three various levels. First, we'll see the physical level, and then next we have the logical level, and next we have the view level. So in physical level, we are actually trying to describe how a record is stored. So how it is going to be physically actually stored on the particular physical actual storage in a database, like how on the disk, how it is going to be arranged, on which segment and on which file it is going to be actually stored. So it's related to actual physical storage of the data, on which disk, on what core it is actually stored. So that is how the physical level is actually going to be, physical level of data is going to be hidden. So what is the next level is the logical level. This level actually describes the data stored in the database. So how it is going to be stored in the database and the various relationships among the data. So let us consider we have a student database, student table with the following information like registration number, name, degree, mobile, and all the student related information is going to be available in a particular student table. So we are trying to describe how the data is going to be stored. For example, if it's registration number, the type of data is going to be an integer. The type of student name is going to be, data type is going to be string. So the degree what the student is obtaining is going to be a string. So we are going to describe the data, actually the data description. So how it is going to be available in the database, and the various relationships from one data to the other data. As we all know, relational model is a collection of relational tables, right? Tables, relations, or we call it as relations in relational model. So we have the various relationships among the data is also going to be available in the logical level. So that is going to be hidden. So in physical level, how the record is actually stored on the physical storage on the hard disk. So that is going to be hidden. And what about your logical level? How that is the structure of the data. It's going to be hidden. So that is the logical level. So first we need to know what type of data and how the data is actually stored in the various levels. So in physical level, how the record is stored, actual storage, physical storage. In the logical level, the data description as well as the relationships among the data, actual storage in the database, how it is arranged. That is the logical level. And next one is the view level, how the the end user is going to look at the data. So after hiding all the complexities, only few information is going to be, that is the essential information is going to be available for the users, right? So how the application programs are going to hide the details of data types. So all that we'll see in the view level. So in your logical level, we have you know how the data is going to be stored. Number is going to be in terms of integer. Whereas in view level, those information is going to be hidden, and users will be able to just know that yeah, registration number, name. So these information can be fetched and accessed. So that is how the application programs are going to access the data that is going to be visible to the user also. So views can also hide information like that is student's mobile number or email for security purpose. Even sensitive data can be hidden. So in this example, we are just considering the student data. So any sensitive information they need to be restricted from the users to from viewing the data. That also can be done in the view level. So in physical level, I think you can now know what data is actually stored, in what level of complexity the data is actually stored in physical level, logical level, and view level. In regard to that, in those levels, that particular complexity is going to be hidden. Okay. So in view level, the user views can hide information in terms of to for security purpose, mainly for security purpose, and also access control for maybe users can for example, let us consider banking information. Certain information has to be hidden from customers. They should not view the detailed information about the other customers information. So some sensitive data can be hidden. So all these are the various levels of abstraction, and based on this only we have the various views of data. So we have one physical level, a logical level, and you can see n number of views are available in the view level. So for each type of customer, the roles or the persons playing role in the database environment, we have different view levels. So we have a student database. A student can view his information or the department information in a particular perspective, and a faculty or the staff can view the department information in a certain perspective, and HOD can view the information in a certain perspective. So based on different perspectives of different roles played by the users in the environment, in the database, in the university or in the department, we have n number of views. That's why you can see the view level alone is numbered, view 1, 2, 3 till n. Okay. So in your database, we have physical level, logical level, and n view level. So we should also know what is an instance and schemas. And we have two types of schemas, and related to that, we'll be talking about data physical independence and data logical data independence. So we need to know what is an instance and schemas. I think hope you're all aware about what is a schema. The logical structure of the database, that is the design of the database, like the database information, like student information, like departments and student is available in a database, and relationship among those two tables is going to be established. Now that is one logical organization of the particular database, one design of the database, how the data is actually represented and how it is related with each other. So this is called as a schema of the database. So what is the instance of a database? At what one particular point of time, what data is available, that is a snapshot of a particular database at a particular point of time. What all is available, how many records are going to be available in a particular point of time. So that is called as an instance. Now, we have two types of schemas. Since I think related to the views of abstraction, the what we saw just now, we have types of schemas also, physical schema and logical schema. So what is physical schema? Database design at physical level, and it relates only with the physical structure, like examples like data files, control files. You can see some examples here. And what about a logical schema? The database design at logical levels and related only with the logical structure of the data. So we should know two types of schemas are available, logical schema and physical schema. So any change you do to the physical schema should not be influencing the logical schema. Same way, similarly, the logical schema, it should not disturb the physical schema. So in that way, we have to design and arrange our structure, or we have to arrange the structure of the database. So with related to instance schemas and what we saw, the design of the schema, we have two types of schemas. So what is physical data independence? So to understand this only, we just saw what is physical structure and logical structure. So what is physical data independence? the ability to modify the physical schema without changing the logical schema. That's what I was trying to tell now. We should actually we should be able to modify the various schemas, whether either it is physical or logical schemas, without changing the next level of data. Okay, so that if you are able to achieve, then that is a proper design, and that is called as the physical data independence. So applications depend on the logical schema. So that is the application programs will depend on the logical schema. In general, the interface that is actually acting as an interface between the various levels and components. Okay, so one level should change should not influence the other level. So that's the intention. So needs for data independence to improve the quality of the data and also the easy maintenance of the database management system. And if you want to achieve the database security, we need to go for data independence, and developer need not worry about all the internal structures. You just concentrate on the programming part alone, the development part alone, and easily we can make the changes in the physical level so that we can improve the performance. So what is physical data independence? It is defined as to make the how we are going to make the changes in the structure of the physical level. So we all know what is physical level. There's a lower level of the DBMS without affecting the logical level. So if you're able to make that particular change without affecting the logical level, then it is going to be physical data independence. Okay. So some of the changes in physical level examples, what is the possible changes we can make, like changing the storage devices or changing the file organization techniques, or if you want to modify the index or modify or change the data structure, so or migrate the database from one drive to the other. These could be the possible changes that are possible with the physical level. So these changes should not affect the logical level or the view level of the data. So if you're able to achieve that, then it is called as the physical data independence. So what is logical data independence? It is defined as how we are going to make the changes in the structure of the logical level or the view level of the data DBMS without affecting the physical level or the low level. So some of the changes in the logical level, let us see an example right here. Adding a new attribute or modifying or deleting an attribute, or if you able to merge a record or split a record, all this related to the logical organization, that is structure of the database. So that's what we saw as the logical design or the logical schema of the database, right? So in that way, these could be some examples that what we are trying to make changes in the logical level. So any changes you try with the logical level should not affect the physical level or the view level. So that's the intention. So what's the difference between physical data independence and logical data independence? So in physical data independent, it is concerned with the storage of the data. That's what the actual storage, how, where, in which hard disk or which, where it is actually stored. Whereas logical data independent is concerned with the structure of the data definition. So data definition, how the structure is arranged, how the data is going to be stored in the database, and what relationship is going to be available within the data. All that is going to be the structure, data definition. The second point, physical data independent is easy to retrieve, whereas the logical data independence is difficult to retrieve because of the dependency on the logical structure. And then the third point, in physical data independent, it is easy to achieve compared with the logical data independent. That is, we can achieve the independence easily for your physical data, physical structure or the design, whereas it's difficult to achieve the independence, logical data independence comparatively with the physical data independent. Little bit difficult. And the fourth point related to physical data independence is it is concerned with physical schema, and here it is concerned with the logical schema. So this is a difference, major what comparative study on the difference between physical data independence and logical data independence. Thank you.